एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि.
We have been continuously conducting every year this international conference. Through this, mainly our college will be globally recognized, and it's mainly for our research scholars, faculty, for them to learn what's how latest technologies in the similar kind of topics to learn. It's like a happy learning.
Then we have to pre-process the data. Pre-processing is required because there may be the data may be noisy data, or maybe there is a requirement of to balance the data sets, because if the data set is not balanced, our model we cannot perform well. So we need to pre-process the data, and then finally we have to train the models. So different kind of machine learnings and deep learnings models will be there, which need to be trained, and after that as a classified, different classifiers will be there. As a result of that, we can actually identify the activities, which kind of activities is there. So this is just that the general overview or the pipelines of human activities based systems. And next we'll see the types of human activity recognitions, which I told you. So we can generally categorize the human activities like wearable sensor based, extrinsic sensor based, and the vision based. This I told you, like computer vision, where the images and videos will be taken care and that will be processed. So in the vision based, what will happening, we are using optical sensors to collect the images and that videos features from the data, and then we have to actually process that data to get the human activities. And some hybrid approaches is also there, where both the vision based as well as that the sensor based data will be combined to get that. And this process may be online as well as that offline mode. So in case of online mode, we have to consider and we have to deploy the models into the cloud and server, so that we can get some kind of real-time processing, and that results can be processed further. And why actually this human activity recognitions, why we are doing the human activity recognitions, this is the questions. There should be some kind of applications. So definitely there are applications of human activity recognition. So if we talked about in kind of healthcare domains, so basically that one of the application is the patient monitoring systems. So that will be very useful tool, and if we are actually that healthcare provider and healthcare support, actually they will actually monitor that patient details and patient's behaviors based on that the sensor data, what kind of patient's behavior is there, if any kind of abnormal effects are there or abnormal activities is happening. Accordingly, that healthcare provider will provide the assistance to that the patient, so that that complete and permanent care can be performed for that patient. And then fall and unusual detections, like that we are actually knowing about that smart watches are there, where that they are collecting the data, and based on the data they are actually generating kind of that body behaviors. Or let's suppose the fall detections, or we can say the fall accident detections. If a person is walking, if the person is jogging, and if some kind of accidental fall occur, that basically the devices which he or she is wearing will generate some data that will be the uneven data. Normal data will be like, if the walking data is there will be some range of data, so that he or she will be walking. If something unusual happens, that's like fall is happened, then that device will actually generate some kind of alarms, and that alarm can be actually linked to some kind of central processing units, or we can say the central server, or maybe that family person, so that signals can be go there, and that can be detected as a fall. So that immediate solutions or immediate support, like if we have some nearby health centers are there, where that can be send some kind of like ambulance, quick ambulance, so that we can save somebody's lives. Okay, so these kind of applications are there based on this human activity recognitions. And like elderly care, so everybody in in the everyone house we have the elder peoples, and if we have these kind of devices like the sensor data, we are collecting that devices, so we can monitor their actually movements, whether it is a normal movements or the abnormal movement, so that that can also be like a smart kind of solutions which we can deploy to our home itself also. Like next applications will be the sportman routine activity recognition. So like a sportmen, they are doing very activities like their pose and their posture, different activities are there. So we need to actually, that can help to actually judge whether their posture is okay, fine, whenever they are doing their practice sessions or they are doing any competitive sessions. So that can be provides that support, so that any kind of unusual injuries will not happen. So that is also will be taken care using this kind of thing. And also the biometric authentication. So that human activity recognitions can also play a role of biometrics authentications, because unique persons can have a unique way of walking, unique way of running. So the difference between the walking and runnings may be unique. So that can also be deployed as a biometrics authentication systems. And similarly, the gait analysis is there, and then energy expenditures predictions also. Okay, so based on the data, we can consider, we can calculate how much the energy is consumed for the particular persons. So what will be the metabological rates, and what kind of the consumptions of energy level is there, so that finally it can overall that human health can be actually, we can get some kind of support to give that analysis of the human health. So these are the some applications of human activity recognitions. Now that what we are talking about, the wearable based human activity recognition. So what kind of sensors basically we are using for that? So this is actually the list of sensors, that accelerometers, gyroscopes, pedometers and magnetometers. So this sensors, basically the accelerometers and the gyroscopes, it is available in our smartphone. Okay, so easily we can actually collect this sensor data from our smartphone. We have to there are some apps are there like in that mobile. So motion sense kind of apps are there. From that app we can actually we can use our mobile phone as a smartphone. So that we can use keep the mobile phone in any of the front pockets, or we can also actually attach the mobile phone in any arm. So while running, while walking, while jogging, we can collect that sensor data, and that can be recorded and it can be processed further for detecting the activities. So the popular locations, the mounting locations, like we can mount that mobiles in the waist, in the pockets, any arm and leg. And we have to whenever we are collecting the data sets, we need to see that that should be standard. Data set should be standards, like we have to see the variability in the genders, both male female data should be collected, and we have to see that age group. Okay, so the data should be collected from different age group. It should not be like from the same age group. And we have to see that physics of the human, or that the users where we are going to collect the data, and also the health set. So these are the user sets while we are going to collect the data. And then what kind of advantages are there using, if we are doing the human activity recognitions using the wearable sensor devices. So basically that the presences of user is user privacy, because whatever data we are collecting through the sensor, this is the text data. And in the other hands, if we are talking about the vision based human activity recognitions, where we are considering the images and the video, so that privacy is involved there. But in the sensor based or wearable sensor based human activity recognitions, we are taking care about the privacy, because these all data are the text data, so that the user's privacy is not disclosed. And then these are the ubiquitous in natures, whatever the sensor data, and this requires that low time for the processing, as well as the space complexity of the sensor data is low. That's why nowadays the that human activity recognitions using variable sensor is now the popular one, and it is widely used for different applications. Now we talked about that what will be the recognition chain for variable sensor devices. If we are going to collect some data, we are going to make a models to detect the human activity using variable sensors. So these are the some consecutive steps are there. So first of all, that will be human will be there. So we have to choice of sensor is required. What kind of sensor data we are going to collect, and what are the sensors, like as I told you that accelerometers and the gyroscopes are there. So these are the available smartphones, so we can use that. And then what should be the mounting choice, where we have to mount the device to collect that informations of, or we can say the collect the sensor data. So it may be like we can use as our pockets. We can keep the front mobile set into the front pocket, or we can also attach the mobiles to our one of the arms kind of things. And we need to take care about the user set. This should be complete, and we have to consider that age variations as well as the physics, as well as what about that male female ratio also we should mention, so that we can come up with the standard data sets. Once the data set is standards, we can expect that the model performance will be good. Then after this data collection, we can have local machine servers, and then we can deploy the data into the cloud also, and this data can be stored in the mobile phone also. Once the data is collected, we need to pre-process the data. So there are steps, there are number of steps are there to pre-process the data. So first of all, we have to taken care about handling the noise and missing values. Whenever we are collecting the informations or the data, some part of the data may be missing. So we need to take care about the missing values. If the missing value is present in the data, either we need to remove that particular set, or we can say the particular row of the data, or we need to replace the missing value with some kind of averaging kind of things. We have to make the average of all others data, and we have to fill up the missing values, as well as if that noise present in the data, so we need to take care about that noise also. It may be for that we need to process the data. Then data visualizations and the exploration will be there. Then after that, we have to take care about the outlier detections and removals. If any kind of outlier is present in the data, we have to find out, and appropriate measures should be taken care so that the outlier of present in the data set should be removed. Then if there is a problem of the class imbalance problem, so that we need to take care. So class imbalance problems, I think you must be aware about the class imbalance. Okay, so whenever we are having, let's suppose we are going to detect 3-4 activities like walking, jogging, running, and if the data sets will be not balanced, maybe your training set should be balanced with all kind of activities. If not so, then we have to taken care of that class imbalance problems, and we have to provide the sufficient data so that that can be taken care. And then after finally we have to do the features engineering. Feature engineering is required in case of if we are doing that using the machine learning models. For that we have to actually accept the features manually, and then based on the features we have to train our models, and then that data normalizations and the standardization will be required. Finally, once this data pre-processing steps will be done, then we can use different kind of machine learning models and the ensembles models to actually train the models, and for that we can make the ratio of 80-20. So 80% samples will be considered for the training part and 20% for the testing part. So there are several machine learning models like KNN, decision tree, SBMs, and these are the ensembles models are there, extra tree classifiers, cat boost, extra. So these models will be there. So based on that we will train our models, and along with the trainings we need to validate the model. Once that model validation is complete, we can apply some test data so that finally as a result of that we can get the different activities, okay, like walking, running, jogging, upstairs and downstairs. So this is the complete cycles for wearable sensor based human activity recognition systems. If any doubt is there, you can ask me any questions, because I'm just going fast because these are some standard procedures with a machine learning model. So I think it is not required to discuss in details. If you have any doubt, you can ask me. We can discuss something here. Otherwise, I have to go ahead. Okay, so as I told you, we can deploy the machine learning models, or we can deploy the ensembles models, as well as some of the deep learning models we can also use for wearable sensor based human activity recognition. So I just categorized here different learning paradigms. So first one is the shallow learning algorithms, where we can use our normal classical machine learning models like decision tree, KNN, Navi based and SBM based. And similarly, we can have some ensembles learning models. So these are the ensembles models. And what are the advantages of using these machine learning or ensembles models, and what kind of disadvantages are there? So this slides basically actually focus for that. So if we talked about the machine learning and ensembles model, so we need to basically the training is required less. We can do this with a less amount of data, and that validation time is also less. That will easy to implement, and we are doing very minimal parameter tuning in case of machine learning models, and these kind of models are very less data hungry as compared to deep learning models. So if we have a less amount of data, we can do the modeling with normal machine learning classical models. And basically that if we talked about the disadvantage, so that requires manual features engineering. So that is one of the actually drawbacks of this. We need to extract the features manually, and then we have to process these features also. And for that there is a requirement of the domain expertise in this kind of learning models are so complex in comparison to the machine learning models. And the major issues with that rigorous hyperparameter tuning, because based on the data sets we need to do the hyperparameter tuning. So different kind of hyperparameters will be there. For that we need to adjust, and we have to come up with the optimum hyperparameter setting. So what kind of optimum values are there, so that can be gives the better results and the best performance. So that is the major rigorous task, and that training will be high, and the validation time training, both validation as well as the training time will be higher in case of deep learning models. And another categories is like fuzzy logic system based. So here we can use the fuzzy rules basically. So that is also one of the way of performing the wearable sensor based human activity recognition. So I just give you the overview of the different paradigms used for this process.
Sir, I have a question.
Yes.
When we are using fuzzy logic and we are using machine learning concept,
Yes.
which do you feel better than?
Basically, fuzzy logic we have to give up some kind of rules based. Okay. So both are good, but machine learning is what we are actually we have to deal with the data. We have to feed the data to the models, and that will give some kind of classification results. But in case of fuzzy logics, we have to do some more analysis. We have to come up with the mathematical rules. So that rules formations is required. So both may be equally good.
There also we are doing fuzzification.
Yeah. Yes.
Which is almost like training.
Yes. Because that rules we have to validate whether the rules are validated or not. Because whatever we form the rules, we need to take care about the validations also.
Yeah, I have a couple of questions maybe related to the previous slides. One question is about the data collection. Are you collecting the data on your own, or are you using?
Yeah, we have actually there are some standard data set is also available, and our research group is also collecting some data sets. I will be coming with these slides, so where we will show how we are collecting the data sets. So because whatever the data sets are available nowadays, they are in the control environment. So the data collection is performed in the control environment. Control environments means that maybe in the closed rooms and where the noise are very less, and we do not require so much pre-processing in the control environment data sets. But actually when we are going for real-time situations where we are not going to have the control environment data, the data will be collected and collected in the uncontrolled environment. So that is a basically more challenging task to how to deal the data which are collected in uncontrolled environment. So that challenge actually we are taken care, and we are also collecting our own data sets, and for the validations of the data sets we have do the modeling. We have a models. We actually test the models with the standard data sets as well as our own data set collected, whatever the data set we have collected. So to see that how much actually our data set is validated, how much it is standard. So we are going to, I am coming to that slide, so I will let you know in more details about this thing.
The second question is actually one of the applications what you have posed was finding the abnormalities.
Yes.
Now, in the other slide also you said that you wanted to remove some kind of outliers. Generally, the abnormalities are nothing but it is an outlier. So when you are removing the the outlier,
So
then automatically you are also
yeah,
removing the
I can
abnormalities.
understand. Thank you. That's a very good question. So based on the data analysis, okay, we need to see, and we are not going to delete the outliers. We have to just analyze the data sets. How much variations is there in the data sets, whether all are the normal data sets, and if so, because when we are going to collect the data from the smartphone device, so we assume that whatever will be the samples collected in the last portions of the data sets, because when we are stop recording of the data set, that times some kind of noise or some kind of outlier may be because of that the device which we are from where we are collecting the data sets, from that also that can come. So we are actually first we have to analyze the data. We are not directly coming and deleting the outlier or removing the outlier. We have to do the data analysis, whether this is that due to the device or due to basically that uneven fault. So that we need to analyze, then only we have to perform that removal of the outlier. Sometimes it is not required to remove the outliers, sometimes it is required to remove the outlier. So that analysis we are actually performing in parallel. Okay. So these are the basically the key challenges which we are discussing now. First of these annotations issues, because the training and evaluations of deep learning models requires large amount of data, and this is very highly expensive to categorize, collect and annotate that sensory data sets. Okay. So we have to see which, because when we are collecting the data sets, we have to annotate the data also, whether this data is basically belongs to the walking activities, or maybe the running activities, or maybe jogging or upstairs downstairs. So that annotation is very expensive in case of deep learning models. So that is one more the challenge. Outdoor activities basically perform the subject basically mostly collected in the control and the lab environments. Okay, that is that possibilities of real-time implementations is a challenge, because we are looking for the outdoor activities, and that may be different from the control environments collected data. So as whatever the activities are we are going to detect, that are basically performed in the outdoor. So that is one more challenge about the data collections. And the class imbalance and basically issues like the accident, unsupervised fall is the major challenge, and it is basically difficult to get this kind of data, because the normal data we can get. If we are walking, we can collect. Let's suppose if any kind of fall occur or any kind of accident occur, for that data collection is very tedious job, because this data set we cannot get in the real time, because nobody have that much samples for the accidents, the fall. Very few samples will be there, but to get this data set, it is also the very challenging task to make a data set balance. We can have a normal activity data set, that is fine, but abnormal activity datasets collections is very tedious job, which is not very much available in that literature.
Yeah, one more actually problem in imbalance is there could be a age gap.
Yeah. So that I told you now before data collections, we need to taken care about the age. So that data sets should be standard if we have all kind of ages data. So model will be trained well if we have a different kind of data, different kind of ages data, then we can consider the model is trained well. Otherwise, that model will be performing well for a specific kind of data. So that need to be taken care. And then hyperparameter optimizations. If we talked about the deep learning model, so we need to see different hyperparameters like the number of layers, convolutions layer, filter, size of filter, the neurons, epochs, and so these are so many hyperparameter tuning is required. And multimodal sensor activities. So we have to taken care about which if we are considering that multiple sensor kind of thing. So this can also be actually is a one challenge if we are considering the multiple sensor. And cross data sets is also one of the challenge where we have to see discrepancy between the training and the testing data with the person independent data. So these are some key challenges of that variable sensor based human activity recognitions. And these are the data sets which are actually available and it is publicly available. So we can download these data sets and we can train our models and validate also. So like HARSense is there where they have considered 6 human daily life activities and number of subjects will be 12 here, and they have considered these 2 sensor A and G. A is for the accelerometers and G is for the gyroscope while collecting the data, and mounting positions of that device will be in the waist and the pockets, and the data set is collected in the control environment. Similarly, we have there are other data sets. So these all initial 6 data sets actually collected the data into the control environments, and we have some few data sets, and these are also publicly available, which have collected the data set in the uncontrolled or the real-time situation. So like these are the HR and M health and the motion sense data, and similarly they have considered the sensor like ECG also, accelerometer, gyroscopes, and then magnetometers, and their mounting positions are the ankle, wrist, and the chest while collecting the data. So this is just the details of the publicly available data sets. We can have these data sets, we can use these data sets for our purpose, research purpose. Now these are the effect of environments while we are going to collect the data, like the variable, the time consumptions, and what will be the advantage and the disadvantage of the control as well as the uncontrols. So these are the differences if we are going to collect the data in the control environments and the uncontrolled environment. So if we talked about that area or field, so the control environment we will consider a closed room or laboratories for collecting the data, and in uncontrolled we are considering the outdoor playgrounds, roads, and the streets while collecting the data. The variables will be speed, velocity, rotations. These are all in the control in nature, while in the uncontrolled these are not in basically subject to that the own limits and the tendency to perform by the human activities. That time is less while we are collecting the data in case of uncontrolled as comparison to uncontrolled environments. Here the time will be more as compared to the control environments. The advantage, like we can achieve good training and validation.